definitions here. You look at the top, it says parallel lines and then angle relationship. So the big thing that you're going to hear a lot of for the next few weeks when we were doing these problems, what's called a transversal. So we need to make sure we understand that definition. It's probably a new word to you. All right, a transversal is first and foremost a line. It could also be a segment, array. All right, so in this case, we're saying a line. It is a line that intersects two coplanar lines. So it's got to run into two different lines that lie in the same plane. Okay, nothing we do is in a different plane at this point, so you don't necessarily worry too much about this word. And it's got to intersect at two different points. So if we look at this here, this guy here is what we would call our transversal. Notice how it is a line that's intersecting two different lines. All right, line A and B is cut by this yellow line. So this guy here is what we would call our transversal. And we're going to use that a lot. When that happens, it forms a bunch of different kinds of angles. So that's what we're going to talk about down here. Angles formed by a transversal. All right, so the next thing, it says alternate interior angles are formed by two lines and a transversal. Well, that's what we have up here. We have line A, we have line B, and then we have our transversal. The angles must alternate sides of the transversal in the interior of the figure. Here's what that means. So if this is our transversal and these are our two sides, the interior would be inside of the other two lines. So kind of think of this as the inside part of the other two lines. So that's why we're using the word interior in that definition. But you're also going to see where it says alternate. It needs to be on alternate sides of the transversal. So if the yellow part is your transversal and we need to be inside, the angles that are alternate interior angles would be angle 4 and angle what? What is the other angle that's inside but on the opposite side of your transversal? Ella? Good. Angle 6. Those are alternate side of the transversal. They're inside of the other two lines. So you're going to say angle 4 and 6. So when I say name a pair, you're going to say angle 4 and angle 6. However, there is another. So just to make sure we understand, there are more. Angle 3 is inside of the two lines. And if we look at angle 5, it is also inside. And notice how they're on opposite sides of that transversal. So angle 3 and angle 5 are alternate interior angles also. All right. So again, opposite side of the transversal, inside of those two lines. All right, next one. Alternate exterior. Actually, let me do this while I have it shaded. Go to this definition here while I have it shaded in the way that I currently have it shaded. So find this definition here where it says same side interior angles. Be good to kind of compare and contrast the ones we just did. So again, what this is telling us is we need to be inside of the two lines. So if I look at my two lines up here, that's the stuff that I have shaded in blue. So let me erase all of this. So here's inside of the two lines that the transversal is running into. We now want them to be on the same side of our transversal. So there's only 4 angles inside: angle 4, angle 3, angle 5, and angle 6. If you look at angle 4, the angle that is also inside and on the same side of this is angle 5. So these are same side of the transversal and they're interior. So angle 4 and 5 are your same side interior angles. So underneath that one, you're going to put angle 4 and angle 5 are same side interior. And then put a comma and write the second set then, without me moving mine. So look up at your shape on your paper. We want to be inside the two lines and we want to be on the same side of the transversal. There should be another set of same side interior angles. Okay, what set are we talking about here? What's our pair? Armando? Good. Angle 3 and angle 6, they're both on the same side of this transversal. They're both inside of the other two lines. So 3 and 6 are the other pair of same side interior angles. Okay. All right. So that's those. We also have, now if we go to this next one, that's actually on your paper. So now find where it says alternate again, but exterior. So now hopefully, if we understood the idea of being interior, let me erase all of this. If this is the interior, the inside of those two lines, then the exterior would be the stuff outside of the lines, above and below the two lines. Okay, so the shaded stuff in blue, we consider those the exterior angles. So angle 1 and angle 2, angle 8 and angle 7 are exterior angles. All right, so that's first and foremost, just understanding the word exterior here. Alternate means they're on the opposite side of your transversal. So if we then look at that, all the angles in blue are exterior angles, and then we want them to be on the opposite side of your transversal. So if I took angle 1 here, its alternate exterior angle, if we follow this transversal down, the other exterior angle on the opposite side of these other sets are angle 7. So angle 1 and angle 7 are what we would call alternate exterior angles. All right, then comma, write the other set real quick. So if this is our figure, what's the other set of angles that are outside but on the opposite side of our transversal? All right, and Julia, what do you got? Good. So angle 2 is an exterior angle. Angle 8 is an exterior angle. They're also on the opposite side of our transversal. So angle 2 and then angle 8. All right. And again, while I have it shaded this way, real quick, go to your next page. We'll come back to that corresponding one. We have another set of exterior angles. Label these now. I'll move mine up so you can not have to switch back and forth. Find the same side exterior angles based upon the picture that I have drawn in here. So same side exterior angles. All right, Mo, what is one? Just give me an exterior angle.
Angle 1 and angle 8.
Okay, good. So angle 1 is an exterior angle. And then he said angle 8 because this is an exterior angle. Angle 8 is an exterior angle, and they are both on the same side of the transversal. So angle 1 and angle 8. All right, so that's one of your sets. And then based upon that idea, Julia, what do we think for the other side of same side exterior angles? Good. Angle 2 here and angle 7 there. So those are same side exterior angles. All right. All right. And then last but not least, or what we call corresponding. These are the ones people tend to miss the most. That's kind of why I wanted to do them for last. So here's what corresponding means. If we look at this set of angles, notice how we have 4 angles up here when that transversal crosses one of the lines. We have 4 angles down here. If I look at these angles here, notice how angle 1 is the upper left-hand corner of these 4. Its corresponding angle down here would be the other one that would be kind of the upper left-hand side. So angle 1 and angle 5 correspond to each other in terms of they're both on the same side of the transversal, but they're both above those lines. They're kind of upper left-hand corner. If I go to angle 2, do that. Angle 2, notice how that's kind of the upper right-hand side. So down here, it's angle 6. That is the upper right-hand side. So 2 and 6 correspond to each other. A lot of corresponding, because now if I come down here, 4 is the bottom left-hand corner. Angle 8 is the bottom left-hand corner for that one. And then last but not least, angle 3 is the lower right-hand corner. Angle 7 is the lower right-hand corner. Those are all corresponding angles. Okay? So in your little thing, those are what you would want to write. Angle 1 and angle 5 correspond to each other. All the same shades are corresponding. So 2 and 6 correspond to each other. 4 and 8, 3 and 7. So that's what you're writing underneath corresponding angles. All right. All right, so now let's see what we got out of that. And then as you look at that, when I was kind of keying this up, just making sure we were all squared away for today, I realized I didn't look this close enough before I copied it. So A is fine, but if you look at letter B, see how you just see angle 5? And then down here, see this angle 8? I tabbed over too much. It should say 5 and 8, so those go together. It kind of wraps around a little bit. And then angle 4 should go with that angle 9 that's on the bottom. So you can do this manually if you want. But this should be what you should have on your paper here. All right. All right. So if you fix those, and then we're just going to now compare them. Like when I tell you angle 1 and angle 4, of those 5 options we just listed, what are they? Are they corresponding alternate interior, alternate exterior, same side interior, or same side exterior? All right, so first few we'll kind of do together. So if I found angle 1, so here is angle 1 right here. And then angle 4 right here. So we're really just worried about this line and this line getting cut by this transversal. All right. So as we kind of consider our options here, if we look at this transversal, are angle 1 on the same side or on the opposite side of the transversal? What do you got, Ted? Same side, right? They're both on the right-hand side. So it could possibly be same side interior, same side exterior, could also be corresponding, but none of the alternate words we need to consider. All right. Well, if we look at these two lines, here is our interior of these two lines. Notice how angle 4 is an interior angle. It's inside of there. Angle 1 is not inside of there. So these are not both interior. They are not both exterior. That only leaves us with corresponding. This is the upper right-hand corner. This is the upper right-hand corner. So angle 1 and angle 4 are what we would simply call corresponding angles. They're in the same location, upper right-hand corner of the two lines, and then the transversal that's cutting it. All right. Next one. If you find, so I'm going to erase mine. So if you now find angle 5, so here's angle 5. Here is angle 8. So now we're really just worried about these two lines on the bottom. Again, here is your transversal. That isn't going to change. This is the transversal for all of these. So now angle 5. Notice how these are on opposite sides of the transversal. One's to the left, one's to the right. And then if we look in between, notice how both of those angles are inside of the two lines. So they're opposite side of the transversal. They're inside of the two lines. That's the whole little opposite interior angles. All right. All right, next one, letter C. You do see, it's somewhat of a trick question because this is an old idea as a hint. It's what you've already tested on. So don't necessarily think we're not going to continue to use old stuff. And write down what you think C is. Okay, old idea. So kind of somewhat of a trick question, also very easy at the same time. Aren't these vertical angles? All right, these are across from each other. Of the four angles that are described right here, these are nothing more than what we just tested on Friday. The idea, those are vertical angles. They're directly across from each other, created by those two lines. All right. All right. 4, 9. Last one we'll do together, and I'll have you try E through H, see where we are at with these. So find angle 4. So here's angle 4. Here is angle 9. So we're really only concerned about these two lines here. The line on top, we don't have to worry about it. We can ignore that one. And then our transversal is the line that's cutting through those two lines. And then look at angle 4, look at angle 9, and see what we think. So what words you're thinking of? Are they on the same side of the transversal? Are they on the opposite side of the transversal? Are they inside or are they outside? And then you kind of put those words together. And if it's none of those things together, then they're probably corresponding. All right. So first things first. Let's go. Tomas. What do you think, Tomas? If this is our transversal, are they on the same side or the opposite side of that? Good. So they're on the opposite side. And then if we look at these two red lines, here is inside of those two lines. So then, Tomas, are our angles inside or outside of those two lines? Good. So if they're on the opposite side and they're outside, then that's what we're pretty much just putting together. They're opposite sides, so you're going to put opposite. And then since they're outside of those two lines, that's what exterior means. So those are opposite exterior angles. Okay. Okay, real quick, give you 2 minutes. Do E, F, G, and H, and see if we can identify how those are all related to each other. Because in a minute, we'll see. We're going to go through all the theorems that go with these versus just knowing which ones are which. Okay, let's see where we're at here. All right, Lily, angle 1 and angle 9, what'd you put? Good. They're on, here's our transversal. Angle 1 and angle 9 are opposite sides. And then if we consider, since we're talking about 1 and 9, here's the inside of those two lines. 1 and 9 are also outside of that shaded region. So those are alternate exterior angles. All right, good. All right, F, Karina. What'd you put for F, Karina?
Corresponding.
Good. These are corresponding angles. All right, if we look at angle 2, angle 6, they're created by these two lines. These are both bottom right-hand corner of the 4 angles that those two things create. All right, so those are corresponding angles. All right, 6 and 7, Joe, what do you got?
Opposite view.
Good. Those are, by opposite, we're going to say alternate, but same idea. Alternate interior angles. All right. Angle 6, angle 7, they're on the opposite side of this transversal right here, and they're inside of the 2 lines the transversal intersect. So those are alternate interior angles. And then the last one's there, 6 and 10, Jada. What'd you get, Jada? Good. Those are also what we would call corresponding angles. All right. Both bottom right-hand corners of these sets of 4 angles that are created with that transversal. All right. Okay. Now that we know those, hopefully, we have some theorems that go with these. All right. So in the theorems, it says if 2 lines are parallel. So now the only difference of what we've been doing, and make a note of this as well, the reason we know that line J and line K are parallel, if you're not told it, see how there's little arrows on those lines? Those arrows indicate that these 2 lines here are parallel to each other. They will never intersect. Same slopes, however you want to think about it, however you learned parallel back in the day. These are parallel lines. Those parallel lines are then cut by this transversal. So now this is some unique properties so long as the 2 lines that we're cutting with the transversal are parallel to each other. Our theorems then are alternate interior angles are, and then we're going to put that little symbol, which means congruent. So just kind of use your eye test with some of these because there's only a couple things that can happen. This should say interior. So let's look at some of our alternate interior angles. Walking around, we had a pretty decent understanding of all of these, it looked like. Would an angle 4 and angle 5 be alternate interior angles? So if we just kind of use our eye test, just to kind of understand what this is saying, would it appear that this angle here and this angle here have the same degree measure? Yeah, they're both bigger than 180, a little bit bigger than 180. These are congruent. Alternate interior angles are congruent. So then angle 3 and angle 6 would also be congruent. All right, so that's our first theorem. Alternate interior angles are congruent. Again, as long as they're parallel lines. All right, next one. If we do alternate exterior angles, and then before I tell you what these are, let's just kind of, again, use our eye test a little bit. Angle 2 is an alternate exterior angle to angle 7. So if we are going to think congruent again, if that's a possibility, would it appear angle 2 and angle 7 appear to be the same sort of an angle, same degree measure? Yeah, they're both less than 90 degrees. All right, so it is reasonable to think, and this is our theorem, that yeah, those could be congruent as well. So alternate interior angles, alternate exterior angles are congruent. Okay. All right. So those are our alternate side. We also had some that said same side. So same side interior angles are, and then before I tell you what they are, let's just kind of use our eye test and see what we think. So a couple of same side interior angles. Angle 3, its same side interior angle should be angle 5. So we kind of measured those angles the very first day. I had you kind of do it on that delta math idea. If I look at angle 3 and I look at angle 5, would it appear that those angles are congruent to each other? They have the same degree measure? No, right? The angle 3 is at some point you did all these in your life. Is that a right angle, an acute angle, or an obtuse angle? Or put it this way, is it bigger than 90, equal to 90, or less than 90, this guy? Less than 90, right? If I go to angle 5, is this equal to 90, less than 90, or greater than 90? Greater. So there's no way these are congruent to each other, okay? So same side interior angles are, and then you're going to write supplementary. All right? So simply means we should have a pretty good understanding of what that, we just tested on that. Don't change your writing on your paper. But if this was a 70-degree angle, if angle 3 was 70, then we would know this had to be 110 because these have to add up to be 180. Okay? All right. We also had same side exterior. So get to that point. If we now look at our same side exterior, so here's angle 2. Here is angle 8. They're on the same side of our transversal. They're both outside of the two parallel lines that we're intersecting. Notice again how angle 2 is less than 90. Angle 8 is greater than 90. No way they are congruent. And that is because these are similar to the previous one, supplementary as well. They must add up to be 180 degrees. Okay. And then the last one, we'll finish with this. Last type of angle we identified in the previous 2 pages are corresponding angles. And then you're going to fill this in by just kind of eyeballing them. It's either congruent or supplementary. So find a pair of corresponding angles. And just by kind of the eye test, do they look like they're congruent to each other, or do they look like they need to be adding up to be 180? And then write down what we think. Okay, Mo, give me a set of corresponding angles first, Mo.
3 and 7.
Good. So these are all color coordinated. So angle 3 here and angle 7 here, these are corresponding. Do these look to have the same degree measure, or are they going to have to be supplementary?
Same degree.
Good. Isn't this a less than 90 degrees? This is a less than 90 degree angle. So corresponding angles are back to being congruent. Okay. Okay, stop there. We'll bring this tomorrow because then we're going to obviously do some problems on the next page involving all those properties. And then you'll get some homework on all of this tomorrow. Okay, so you're free for the night.